yesterday we looked at arithmetic series, and we said that arithmetic, of course, means that we've got a sequence where we're just adding or subtracting the same number each time. We've got a common difference. But with a series, that word series, that means add them up. Add them all up. So yesterday we said, okay, if we've got a big list of numbers and we want to add them all up, how do we do that? And we came up with this this nice formula from Gauss. We talked about how as an 8-year-old he came up with this cool adding trick for adding the numbers from 1 to 100 by writing them in order and then writing them backwards underneath. And then he found that each group summed to 101, and so he just multiplied 50 times 101 divided by 2 and got his answer when he was only 8 years old. And then he used this same technique to find this equation for adding up any arithmetic series. And we got this formula here, and you used this in your homework last night. I also gave you another formula that could be used, and I want to give you a little bit of context around that other formula and why we're using it and how we use it. So here we go. I'm actually going to modify this formula a little bit. So we remember that S, of course, stands for the sum of some number of terms. N, of course, stands for the number of terms. A is our first term, also sometimes called T1, and D is our common difference. So here's what I'm going to do. I'm actually going to split up that 2A right here. I'm going to split it up into pieces. I'm going to split it up into A plus A. So 2 different pieces. Okay? And then I've got my N minus 1 and my D. And then I'm dividing that whole thing by 2. So the only thing I changed there was I split up the 2A into A plus A. Now I want you to notice something. If you look right here inside this dotted line, that might look familiar. Why does that look familiar? Well, that's our general term for an arithmetic sequence. A plus N minus 1 times D. That's our general term. So we can actually rewrite this in a kind of simpler way as A plus T to the N. So if we already know our general term, say we're given it or it's easy to figure out, we don't have to plug all of that in. We could just plug in our general term that's already maybe been simplified a bit. So this is a simpler way of writing that formula if you're starting with a bit of extra information, if you're starting with that general term. Now I'm going to write A because we know that A is equal to the first term. A just means the first term. I'm going to rewrite this. So we've got term 1 plus the general term. This would also be considered our last term over 2. And so what I've actually done over here, hiding on the right-hand side, is that formula written in a nice red box. Now, you wrote down yesterday a version of this, but there would have been an A where the T1 was. So what I'd like you to do on your cheat sheets is make sure that you have both of these formulas as they are written here, nice and clear with the big red box around them, because we can use either of these formulas to find the sum of a sequence of numbers if they're arithmetic, if they're going up by a common difference. They're basically the same formula, one is just a modified version. So the one on the right is useful when you've got the general term already. I'm going to put a little note on here just to remind us, and we'll say use if you have general term already, because it can save you some work. Okay, so I'm going to give you 30 seconds to get that written down if you need to make any changes or additions onto your formula sheet, and then we're going to put these to work. We're going to try a few of them. So this will be the same stuff you were working on for your homework last night. We're going to get some extra repetitions on that. All right, let's go for it. Let's try a few of these out. Here's an example. I'm going to do one, and then I'm going to have you practice one. So it says, determine the sum of the first 18 terms in the arithmetic series. So I've told you that it's arithmetic, but you probably could have figured it out, right? By looking at it and saying, oh, there's a common difference. Each time it's going down by 5. So my first term is going to be 75. My common difference is -5. It's also probably useful to say I'm looking at the first 18 terms. So n is going to be 18. So far, so good. Now we need to use that formula. This is one of those ones that once you've written it down a bunch of times, you'll just stick in your brain. So probably for now, you'll need to look it up each time you use it. The sum of those n terms, we know our formula is the number of terms times 2 times the first term plus number of terms minus 1 times the common difference, and all of that divided by 2. Let's sub in what we know to this formula. We know that we want the 18th, the sum of the first 18 terms. We can put in an 18 anywhere we see an n. Where there's an a, we'll put in a 75. Again, where there's an n, we're going to put in an 18. For our common difference, we're going to put in -5. So there, I've subbed everything in, and I'm ready to start doing my algebra. Here's a little trick to speed things up for you. I recommend you use this. I've got the whole numerator multiplied by 18, and I'm also dividing it by 2. So a little shortcut, since this 18 is multiplying everything else on top, I can just go 18 divided by 2, cross those out, and that's just going to be 9. Rather than multiplying everything on the numerator by 18 and then dividing it by 2, I'll just multiply it by 9. So that's a little shortcut that'll save you some work. Some writing. So I've got 9 times 2 times 75 is 150. 18 minus 1 is 17. So actually we'll write that all the way out. 17 times -5, just so we're being extra clear. $17 times -5 is going to give us -85. $150 minus 85 will give us 65. Let's move up here. 9 times 65 is 585. And I'm going to do a little therefore statement. I'll say therefore the sum of the first 18 terms is 585. Okay, I'm about to flip to a new page where you're going to try one. So have your notepad ready. Let's recognize some of the things we did in solving this problem. We started by judging whether it was arithmetic or geometric. This question actually told us that it was arithmetic, which I guess helped a bit, but we could have figured that out on our own. We listed all the stuff we knew. The starting number, the common difference, and the number of terms we wanted. We wrote down our big equation. We subbed in everything we knew, and we noticed the number multiplying out front was an even number, so we could divide it by the 2 on the bottom to simplify things. We did a whole bunch of algebra and got to our final answer. Okay, so that's what I'm going to ask you to try and do right now. Here we go. So first thing we want to do, let's see what we know. When you were looking at this, you would have said, okay, a couple things I need to know. I need to know my first term. My first term is 2. I need to know my common difference. It's going up by 3 each time. So my common difference is going to be 3. I also need to know my number terms is 100. I'm supposed to find the sum of the first 100. So again, our formula, and I'm going to write it down for myself each time because I find it's going to help me remember it if I'm practicing that each time, and then it's going to become second nature. Here's my sum formula. Now let's sub everything in. Sum of the first 100 terms. We've got a 100 out front. 2 times A is 2. N is 100. Common difference is 3. Quick little shortcut for ourselves. 100 divided by 2 is 50. Since that 100 is multiplying everything else on the numerator, we can do that. So that's going to shorten things up for us a little bit. So we're going to end up with 50 times, 2 times 2 is 4. 100 minus 1 is 99. So 99 times 3. So we're going to end up with 50 times 4 plus 297. Let's move that up here to finish. So we got 50 times 301. And that's going to be 15,050. And then we'll say, nice little therefore statement. Therefore, the sum of the first 100 terms $15,050. Ooh, that's a little messy. Okay, so this is like on the more fundamental side of these types of problems. You're going to need to be able to solve this type, because this is the not to say this is necessarily easy, but when you're adding up the sums of sequences, that's about as simple as this can be. Not to say it's simple, but that's as simple as this can be. This is a fundamental type of problem we need to be able to solve. So this is an important one to practice, and there were a lot of those in the homework last night, so I hope you got a good feel for them. Let's take a look at one other type of way this might go. Here's another way this might go. Determine the sum of the first 45 terms in the arithmetic series. This appears to be the same thing, but you're going to notice that I'm not given a list of numbers. So this looks the same. Everything else looks really similar to the question before, but all of a sudden, instead of being given a list of numbers, I'm given a recursive formula. Now, there's 2 ways you can go with this. You could use the recursive formula to figure out the first few numbers. You could use those numbers and then do the problem just like we did on the previous slide. But I don't really want to do that. I want to try using our second formula because I think that'll make solving it a little bit quicker and a little bit slicker. So I'm going to try and use our second formula, and I remember that to use that formula, I need the first term and I need the general term. So I'm going to need to try and get my general term from this recursive sequence. And I can do that. Here's how I'll do it. I'm going to say, okay, what's my first term? It's negative 42. T1 and A are the same thing. So my first term is negative 42. What's my common difference? Well, I can see it right here. My recursive formula tells me take the previous number and subtract 12. So that means every time I'm subtracting 12. That's going to be my common difference. And my n value is 45. Now you could just take these numbers and plug them into your equation, just like we did last time. But I want to show you this in a slightly different way. I want to show you how I would solve this using that second formula. Okay, so let's find our general term. For this arithmetic sequence. Our general term goes like this for an arithmetic sequence. A, your first term, plus n minus 1 times your common difference. Okay, let's sub some things in. What's our starting term? It's negative 42. N minus 1, and then what's my d? It's negative 12. Let's multiply this negative 12 through the brackets. I'm going to end up with negative 12n. And negative 12 times negative 1 is going to be positive 12. So let's add our like terms. I know I've got the negative 12n, but I can add my regular numbers together. So that's going to be end up negative 30. Negative 42 plus 12 is negative 30. So this is my general term. I got my general term. Awesome. I can now use this general term in my equation. My second equation said, okay, the sum of the terms is going to be the number of terms times the first term plus the general term over 2. Let's put our values in. I know I want the sum of the first 45, so I'm going to put in a 45 wherever I see an n. My first term is negative 42. You could also call that a. It's the same thing. My general term is right here, negative 12 times n. N is 45 minus 30. Oof. That's starting to look ugly. We're going to hang in there. Let's simplify this a little bit. Let's get rid of the 45 and the 2. 45 divided by 2 is 22.5. Okay, so we got negative 42. Now, I notice my general term is all in the brackets here, right? So I've got 12 times 45, and it's negative 12 times 45. That's giving me negative 540. And then I've got another 30 subtracted. Whew. It's going to be a big negative number. Let's put all that stuff in my brackets together. Looks like I end up with negative 612. Final step. I'm going to get 13,770 when you add all those numbers up. Thanks for the heads up, Kaylee. I appreciate that. I am recording this, so you'll be able to look at it later. So you may want to just log out. If you can hear me, log out, try coming back in, and then you'll be able to see this recording after so that you can catch what we're talking about. Okay, thanks for hanging in there. Okay, I want you to try this now. We're going to do the same thing. So remember, here's going to be our foci. focuses. I'm going to give you a recursive formula. Oh, yes, thank you, Emma. You're absolutely right. The final answer is negative. I'm so glad you caught that. The final answer is, final answer is a negative number. Which makes sense, right? We're starting at negative 42, and the next term is going to be 12 less than that, and the next term is 12 less than that, and the next term is 12 less than that. So it's all going to be every term is negative when you add them up. Great catch. Thank you, Emma. Okay, so we're going to start with a recursive formula. You're going to use that recursive formula to figure out what your first term is, what your common difference is, and your number of terms will be given in the question. You're going to find the general term by subbing what you know in. By subbing in your A value and your D value. And then you're going to use our second equation, subbing in our first term and our general term and simplifying. Now you might ask, hey Mr. Roy, can I actually get ahead of the game here and sub 45 in for n right here, figure out what that is, and then just plug that into my equation? And the answer is yes, you can do that. That would be a nice little shortcut and would clean this up a little bit too. So that is a fine and legitimate and good way to do it. So you could sub your 45 in for the n right here, figure out what that's going to be for the 45th term, and plug that in. Okay, here we go. We're going on to try this out, so have your notepad ready. Remember, we want to find our A, our D, and our N, and then we're going to try and find the general term, and then we're going to use that second formula. Here we go. All right, the first thing we want to do is see what we know. Well, I can tell right away that my first term, hello, pen, come along for the ride, pen, there we go. My first term is 340. That's the same, A is the same as T1. My common difference is negative 22. It's going down by 22 each time. The number of terms I'm going to add up are 45. So that's what my n value is going to be. If I want to find my general term, I'm going to say my starting term time plus n minus 1 times d. Let's put in our values for that. 340 is what we start with. D is negative 22. So I got everything subbed in. I'm going to multiply that negative 22 through the brackets. Negative 22 times n is negative 22n. And negative 22 times negative 1 is positive 22. So I'm going to end up, when I add all these together by collecting my like terms, I'm going to end up with 362 minus 22n. So that right there is my general term. That's going to be useful for me. Now, if I want to take a little shortcut here, I can just sub in 45 into my general term and see what I get. What's that 45th term? So 362 minus 22 times 45. So I'm going to end up, that term is going to be negative 628. Okay, so now I can plug that into my equation. I say, all right, my sum equation, one of the ones I can use is my first term plus my general term over 2. If I want my 40, the sum of all the terms up to term number 45, it's going to be 45 times my first one is 340 plus, well, I'm adding a negative number, so that's like subtracting, over 2. So now that's just a matter of calculator work, right? So 340 minus 628 times 45 divided by 2. I'm going to end up with negative 6,480 when I add all of those terms together. Okay, so now we know 2 formulas, 2 methods for finding the sum of an arithmetic series. There were some really good questions that some students asked me about the homework. There were some tricky ones on there. I think what I want to do, because I want to do an introduction to the geometric series today, that's actually going to be quite short, but I want you to practice that tonight, so that'll take us maybe 20 minutes, so that'll be perfect to end the lesson today. The homework questions I actually want to make a separate video, so as soon as we're done class today, I'm going to make a separate video of those questions that students sent me about the homework, and I'm going to post that on today's lesson. So I'm going to stop this video here, and then I'll show you what that would look like.